Hello everyone, welcome back. This is Pavitra, pursuing Computer Science and Engineering at Sri Venkateswara College of Engineering, and my today's subject is Introduction to Civil Engineering. Today I am going to discuss about the topics solid waste management, categories and sources of solid waste. Table of contents. Introduction to solid waste management, types of solid waste, waste processing and treatment, public education and awareness, conclusion and future outlook. Introduction to solid waste management. Solid waste management refers to the collection, transportation, processing, recycling, and disposal of solid waste materials. Proper solid waste management is crucial for public health, environmental protection, and sustainable development. It involves various strategies to minimize waste generation and maximize resource recovery. Types of solid waste. Solid waste can be classified into various categories such as municipal solid waste, construction and demolition waste, industrial waste, agricultural waste, electronic waste, commercial and institutional waste, and hazardous waste. Municipal solid waste. The largest source of solid waste is municipal solid waste generated by households, business, and institutions. MSW includes everyday items such as paper, plastic, food scraps, and yard waste. Proper management of MSW is essential to reduce its impact on landfills and the environment. Construction and demolition waste. Construction and demolition activities generate a significant amount of solid waste, including concrete, wood, and metal. Proper disposal and recycling of construction waste can reduce the environmental impact of these activities. Implementing waste reduction strategies in construction projects is essential to minimize waste generation. Industrial waste. Industries generate a variety of solid waste, including manufacturing byproducts, packaging materials, and hazardous waste. Effective waste management practices such as recycling and waste to energy technologies can help industries reduce their environmental footprints. Regulatory compliance and population prevention are key aspects of managing industrial solid waste. Agricultural waste. Agriculture produces a substantial amount of solid waste such as crop residues, animal manure, and packaging materials. Sustainable agricultural practices such as composting and organic farming can help reduce the environmental impact of agricultural waste. Proper disposal of agricultural waste is essential to prevent soil and water contamination. Electronic waste, also known as e-waste, includes discarded electronic devices such as smartphones, computers, and televisions. E-waste contains hazardous materials like lead and mercury, posing a risk to human health and the environment. Proper recycling and disposal of e-waste are essential to prevent environmental pollution and promote resource conservation. Commercial and institutional waste. Commercial establishments and institutions such as schools and hospitals generate a significant amount of solid waste. Implementing waste reduction strategies such as composting and recycling programs can help reduce the environmental impact of commercial and institutional waste. Collaboration between businesses and governments and communities is a key to developing sustainable waste management practices. Hazardous waste management. Hazardous waste requires special handling and disposal due to its potential risk to human health and the environment. Treatment methods for hazardous waste may include chemical, physical, or biological process to neutralize or detoxify the waste. Strict regulations govern the management of hazardous waste to protect public health and the environment. Solid waste collection. Collection is the first step in the solid waste management processes and involves picking up waste from homes, businesses, and public areas. Efficient collection system helps prevent littering, reduce health risk, and ensure proper disposal of waste. Collection methods vary and can include curbside pickup, drop-off points, or centralized collection centers. Waste transportation. Once collected, solid waste is transported to treatment facilities or disposal sites using trucks, trains, or other vehicles. Proper transportation is essential to prevent spillage, contamination, and illegal dumping of waste. Transporting waste over long distances may increase cost and environmental impacts. Waste processing and treatment. Waste processing involves sorting, shredding, composting, and incinerating waste to recover valuable resources to reduce its volume. Treatment methods like composting can help convert organic waste into nutrient rich soil amendments. Advanced technologies such as waste to energy plants can generate electricity from burning solid waste. Recycling and resource recovery. Recycling is a key component of sustainable waste management that involves turning waste materials into new products. Recycling conserves natural resources, reduces energy consumption, and helps decrease greenhouse gas emissions. Resource recovery facilities can extract valuable materials from waste streams such as metals, plastics, and paper. Landfill disposal. Landfills are engineered facilities designed to safely contain and isolate solid waste from the environment. Modern landfills use liners, leachate collection systems, and gas capture mechanisms to minimize environmental impacts. Landfill disposal is often the last resort for waste that cannot be recycled, composted, or processed otherwise. Public education and awareness. Public education campaigns play a vital role in promoting waste reduction, recycling, and proper waste disposal practices. Increasing public awareness about the impacts of improper waste management can help change behaviors and attitudes. Community participation and engagement are essential for the success of solid waste management programs. Conclusion and future outlook. Effective solid waste management requires a comprehensive approach that integrates waste reduction, recycling, and proper disposal practices. Sustainable waste management practices can help conserve resources, reduce pollution, and mitigate climate change. Continued innovation, research, and collaboration are essential to address the challenges of waste management and create a more sustainable future.